8 plus J6 means we are having Z1. Z1 is 8 plus J6, and after that we are having Z2. Z2 is 5 plus J12. Ohm are connected in parallel. So that means Z1 and Z2 are connected in parallel across 230 volt supply. Voltage is 230 volt, frequency is 50 hertz. Sketch the power triangle. We need to power triangle, okay, and calculate the net active power, reactive power, and apparent power drawn by the loads. Calculate the value of capacitor need to be connected across the parallel combination to raise overall the power factor to 0.95. Hmm? Can you hear me now? Okay, so it is a question of power factor improvement. Remember, I told you in the last class the number of topics questions will cover. In that, I include the power factor improvement also. Power factor improvement is very, very important, and one question you will definitely get it in your paper. Okay. See, what is basically a power factor improvement? For that, you need to do a standard thing in every question. You have to make the two power triangle. One is without improvement and one is with improve. Okay. Without improvement means power factor is less, and with improvement means power factor is increased, and by adding capacitor we can improve the power factor. So that is with capacitor and that would be without capacitor. Got it? Now for this case, without capacitor cos phi we need to calculate. With capacitor cos phi they have already given that if they have added the capacitor, then the power factor is how much? That is 0.95 lagging. So power factor is how much? 0.95. One thing that without capacitor and with capacitor, P is always same. Okay, because a capacitor and inductor doesn't change the active power. So this P1 must be equal to P2 always, and we'll use always P1. Next thing, we need to know S1 and Q1. They'll give it directly, or maybe they'll give it in this form, so that you need to calculate it. After that, we need to calculate Q2 and S2. As you know, the formula cos phi is how much? By S. So if you know the value of cos phi and if you know the value of P2, can you get S2? And if you know the value of S2, then can you get Q2? Understood up to here? So after this, we'll make a standard thing, that is Q2 minus Q1 is equal to Q nu. And what is Q nu? Q nu is basically V square over XC. And XC is what? XC is equal to 1 by 2 pi FC. Frequency is also given 2 pi. We know XC we have calculated from here. Then we can put it. Then we'll get C. Okay. These are the standard formulas which we need to use in case of power factor improvement. Got it? This one first. Now the question is, how will you get P and Q from the previous case? As you know, Z is there, so you can combine it with total impedance, that is Z1 parallel Z2. So Z1 parallel is Z2 means Z1 into Z2 divided by Z1 plus Z2. Correct? So it would be, you'll get the ZT, and as you know, V is equal to I multiplied by Z. Voltage they have given, Z you need to calculate, current you will get it, right? And after getting current, you can get the cos phi. Cos phi is what? The angle of impedance is known as cos phi basically. Then you will get cos phi, and after getting cos phi, you will get P is equal to VI cos phi. You will get Q is equal to VI sin phi, then S, right? After getting this value P1, Q1, S1, can you equate P1 is equal to P2? If you'll know the value of P2 and if you know the value of cos phi, can you get S2? If you know the value of P and if you know the value of S, that is, S square is equal to P square plus Q square, can you get Q2? Get Q new. And if you know Q new and you know the voltage they have given, can you get XC? If you know the value of XC, can you get C? That is what they have asked. Value of capacitor. Factory has the I 15. Now they have given different that they are used in factory. The first one cos phi is 0.5 and S is right 40 kVA. For the second one cos phi is 1 and S is 5. Case cos phi is and 10 kVA is given. Can you get P Q P1 1 S1 right? Clearly can you get, because you know the cos phi by S right, and similarly you can get S3 and Q, yes or no? So you combined all this and make a single power triangle. Okay, single power triangle would be plus P similarly Q. Okay, will get T will get, okay. Now you need to get ST. How much? The square. Never do this. Take S is S1 plus S3. Never. Okay. Maximum of the student do this thing. No. But how will you get apparent power? By the combination of total active power and total reactive power. Got it? Hmm. So from this PT and QT, can you get cos phi? That is PT by ST. Right? So that is without capacitor. Now we add capacitor to improve the power factor to 0.9, right? Now with capacitor 0.9 is the power factor. PT same, as I told you, active power is same. Can you get Q new? Yes or no? Cos phi is there, PT is there, Q new, then you will get S new. Again you need to do the same procedure. Q is Q new minus Qt is equal to V square by Xc. Qt you know, Q new you know, V you know, Xc you know. Then you will get Xc and after that you will get C. Right? So it's a long procedure, but it's a question from power factor improvement only that you will definitely get. Okay? Three similar coil, resistance is 8 ohm, XL is equal to 8 ohm and VL is equal to 415 volt. Three phase frequency is 50 Hertz. Now they are asking calculate active power, reactive power and apparent power. First of all, we should know that this is the case of balanced load, right? This is the case of balanced load and you have to remember the formulas that in case of balanced load star connected IL is equal to root 3 of IPH, okay, and sorry, in star connection IL is equal to IPH and VL is equal to root 3 of VPH, and we are having formula VPH is equal to IPH multiplied by ZPH, and ZPH is in the form of R plus JXL if R and L is given, and ZPH is in the form of R minus JXC if it is in the form of RC. Okay. So VPH is how much? That is VL by root 3. IPH we need to calculate, and ZPH they have given 8 plus J8. So we can write it down as 8 plus J8. Voltage, line voltage is given, that is 415 volt. Can you get the value for IPH from here? Phi is the angle between voltage and current, or we can say phi is the angle of the impedance. Okay. So if you convert this 8 plus J8 into the polar form, then you will get some particular angle, and that will be your phi. So in this case, active power formula is root 3 VL IL cos phi. Reactive power formula is root 3 VL IL sin phi, and apparent power formula is root 3 VL IL. You already calculated IPH, so that would be equal to IL. VL you already know, phi you will get it through angle of impedance. Then you can substitute the value, and then you will get the final answer. Don't forget to mention the units. Okay, watt, VR and VA. Now the next thing is, in this question they said that individual wattmeter readings if the power is measured by 2 wattmeter method. So we are having formula of W1, that is VL IL cos of 30 minus phi, and W2 formula is VL IL cos of 30 plus phi. So you already know the value for VL, IL and phi also. So you will get the 2 wattmeter value. They ask you the individual wattmeter readings, means they are asking the value for W1 and they are asking the value for W2. Got it? Now the next question, this is also from Star, they have given from the same paper. The three-phase star connected balance load has an impedance of this one. Whatever they have given it to you, you need to write it down side by side. That Z is equal to 8 plus J6. If the load is connected to three-phase 200 volt, means VL is given 208 volt. The 2 wattmeter method is used to measure the power. Find the readings of the wattmeter, means we need to calculate the value for W1, W2 and the load power factor, means cos phi, using wattmeter readings. So we'll have particular formula for that. That is cos phi is equal to tan inverse of W1 minus W2. Wait. I'll tell you the formula. Cos of tan inverse root 3 W1 minus W2 divided by W1 plus W2. This formula is given in your handbook also. If you'll get the value of W1 and W2, then you will be able to get the value for cos phi also. Also find the total active power, reactive power and apparent power. We need to calculate P, Q and S. Okay. So in this case, we need to use VPH is equal to IPH multiplied by ZPH. No, we don't need current. We need current. Okay. So VPH is known, VL by root 3, ZPH is known. Can we get IPH? See, in this case, we need to calculate the line current. If you see this and this, they are in series. Similarly, this and this, they are in series. This and this, they are in series. Yes or no? Hmm? So in this case, what happens? This is a balanced case and we need to calculate IL. So let's do according to our formulas. As you know, formula is VPH is equal to IPH multiplied by ZPH, right? So ZPH is how much? If I'll add it, it's a balance to 5 plus 10, 15, and minus J2 plus J8 means plus J6, right? So 15 plus J6, that is ZPH, correct? IPH we need to calculate, and you know VPH is how much? That is VL by root 3, correct? VPH is how much? VL by root 3, but they have given the different angles, so no problem, we can calculate different line current, right? Let us consider this one would be IA, this one would be IB, and this one would be IC, right? So I am considering here over IA, and VPH is how much? VL by root 3. So with IA, which voltage is associated? 110 angle 0 degree divided by root 3, right? Yes or no? Similarly, if we can do calculate IA from here, now we need to calculate IB. IB impedance is same, 15 plus J6. Now for IB, voltage is how much? 110 angle minus 120 divided by root 3. Similarly, we can do this one, 110 angle minus 240 divided by root 3 is equal to IC into 15 plus J6, correct? So we can calculate IA, IB, IC, and that is the line current, and in the star connection, line current is equal to phase current, right? One thing. And second thing, that in this supply is also star connected and load is also star connected, right? So it should match with each other. It is also see star connected. Next question, this is from the balanced delta connected. Okay, in the delta connection we'll have the line voltage is equal to the phase voltage, and line current is equal to root 3 times of phase current. And in this, if they mentioned sequence, then VABC means we'll take AB, then B to C, then C to A. So VAB is how much? 330 angle 0 degree. VBC is how much? 330 angle minus 120 degree. VCA is how much? 330 angle 240 degree. Okay. As I told you earlier, first angle is 0 degree, then we'll have minus 120 degree, then we'll have minus 240 degree. Now the formula VPH is equal to IPH multiplied by ZPH. ZPH is how much? 20 minus J15. IPH we need to calculate. VPH is how much? VL by root 3. So 330 angle 0 divided by sorry, not root 3. I this is I have taken AB, so IA will get it. Similarly, we'll get IB as 330 angle minus 120, 20 minus J15. Similarly, 330 angle minus 240, IC 20 minus J15. So after this, we'll get the value of IA, IB, IC. So basically, it is IAB. This is IBC and this is ICA, because we have used voltage VAB, VBC and VCA, right? So these are the phase current. If you remember the formula, IA is how much? IAB minus ICA, right? Remember I told you the formula, and that formula is mentioned in your handbook also. Similarly, IB is how much? IBC minus IAB. ABC sequence. So IC is equal to how much? ICA minus IBC. So these are the phase current, these are the line current. So the standard thing is like this. And if you want to calculate IR, so IR would be how much? Like sequences RYB na R2Y, IRY minus V2R. Okay. Similarly, IY is how much? Y to B, IYB minus R2Y, right? IB is how much? IBR minus Y2. You need to learn, or maybe in your handbook it is mentioned. IBR. So in this case, they are asking the phase current unbalanced delta, right? So IRY, what we can write it here, that is VRY divided by ZRY. Yes or no? Similarly, IYB is how much? IVYB divided by ZYB, and VBR is divided by ZBR. Yes or no? So voltage first one angle RY is how much? 415 angle 0. Second angle is minus 120, means VYB. As I told you, the sequence is RYB, R to Y, Y to B, and then B to R, right? And then we'll have VBR is how much? 415 angle minus 240 degree, correct? So we can put it down the values, that is 415 angle 0 divided by 50 plus J40. Can you get IRY, IYB and IBR? Yes or no? So first part is completed. Next they are asking the line current. Line current means IR, IY and IB, right? As you know the sequence RYB, so IR is how much? IRY minus IBR, right? IY is how much? IYB minus IRY. IB is how much? IBR minus IYB. We already calculated these values. Then can we substitute it in this? But you have to remember that it is subtraction and you will get it in polar form. So do it by the complex method in your calculator. Put your calculator in complex mode, then you will get the value for IR. Okay, understood? And phasor diagram is the normal phasor diagram that you need to draw it like. So this is the case of star connection and unbalanced. See, in star unbalanced, we need to use Cramer's rule. Apart from this, we don't need to use Cramer's first thing. Okay. So in this, they have given you the value ZR is equal to 10 angle 0, ZY is equal to 15 angle minus 30, ZB is equal to 20 angle 45. Now we need to draw the diagram. That this is they are saying for the star connection. This is R, this is Y, this is B, right? So this would be ZR, ZY, this would be ZB. Here the current IR is there, IY is there, IB is there. So in this, apart from the Cramer's rule, we need to apply mesh analysis only, particularly for this case, right? So in this, if we consider current I1, voltage across R and Y is VRY, voltage across VYB is YB. Here the current I1 is flowing and here current I2 is, right? So can we apply the mesh analysis over here? So for that we need the voltage also. First, voltage VRY is how much? Angle voltage they have mentioned 400. First one is 0 degree. YB is how much? 400 angle minus 120 degree. And VBR is how much? 400 angle plus 120. Right? Now we need to calculate. We have to apply mesh analysis. So it would be minus IR ZR. Right? Then we need to write. See, direction of this one and this one is opposite, or we can write it down in terms of I1 and I2. Minus I1 minus I2 ZY minus plus VRY. Yes or no? So can we say that VRY is equal to IR into ZR plus 1 minus I2 into ZY. Now fine. Similarly, we can get VYB is equal to IR I1. I2 minus I1 into ZY plus I2 into ZB. Yes or no? Then apply the mesh by your own. After solving the equation, we'll get the matrix in this form. Now we need to calculate I1 and we need to calculate I2. I1 is delta I1 by delta and I2 by delta. First, we need to solve delta, right? So delta will be this into this minus this. Okay? So you need to do all this thing. First, we'll solve this term, then solve this term, then multiply this one, multiplied by this one, and then subtract it. Okay, I'm writing over here. Suppose it is A1, B1, A2. It would be A1, B minus B1. Okay. Similarly, you need to calculate delta I1. For that, you need to change this term with the first column. So it would be 400 angle 0 degree, 400 angle minus 120 degree, then minus 15 angle minus 30, and 15 angle minus 30 plus 20 angle 45. Okay, again you need to do the same. Now after getting I1 and I2, need see what they have asked. They have asked you the line current. Line current means IR, IY, IB. So IR is equal to I1. IY is how much? I2 minus I1, right? Because I2 direction is same as IY. And IB is how much? That is minus I2, because IB direction and I2 direction are opposite, right? Then you need to calculate phase voltage. Phase voltage is how much? According to the formula, H is equal to IPH multiplied by ZPH. So VPH current you calculated, right? In star connection, line current is equal to the phase current. So IR multiplied by ZA. That is your RN. Similarly, VYN is equal to IY into ZB. VBN is equal to IB to ZC. Okay, they have sorry. They have given RYB sequence now. So ZR, ZY, and ZB. Right? This is the phase voltage. In this question, they said a circuit having a resistance of 12 ohm. We are having resistance of 12 ohm, inductance of 0.15 Henry, and capacitance of how much 100 microfarad is connected in series across a voltage of 100 volt 50 hertz. So whatever they'll give it to you, draw it in the form of diagram. Okay. So now you need to calculate Z impedance, you need to calculate current, you need to calculate voltage across R, voltage across L, voltage across C, and the power factor, that is cos phi. So now you tell me first. Here Z is, we can get it, I we can get it, VR is how much I into R, VL is how much I into XL, VC is how much I into XC, and cos phi is how much R by Z. You have all the values, then you can simply solve it. This is the question of power factor improvement, and every time you'll get this question of power factor improvement. Okay. In this, they have given you three loads. 1, 2, 3. Combined it, make a single power triangle, and then the power triangle with capacitor, right? This is without capacitor. So 80% of the cases they'll give you this one directly. But now we have to calculate this one by using these three loads. First case, P is given 20, cos phi is 1, right? Second case, P is given 100, cos phi is 0.707. Third case, P is given 50, cos phi is 0.9. As you know the formula that cos phi is equal to P by S. P is known, cos phi is known. Can you get this one S1? Then you can get Q1, right? Similarly, you can get S2, then Q2, then S3, then Q3, right? This is P1, P2, P3, correct? So now you need to make a combined power triangle. This would be P1 plus P2 plus P3. That will be the total power. Similarly, here Q1 plus Q2 plus Q3. That will be the total reactive power. So in this case, we need to calculate S. Always remember, we don't calculate S as S1 plus S2 plus S3. No. ST will be always root of PT ka square plus QT ka square. Now see with capacitor, they ask you to calculate total kilowatt, means PT and ST. Okay, and power factor. So power factor in this case, that is PT by ST. In this, they didn't ask you to calculate for with improvement. They ask you this thing only. But they can merge with another question, because in many of the question paper they merge this thing. See, in this question we are having R is equal to 8 ohm, XL is equal to 8 ohm, PL is equal to 415 volt, right? So we need to calculate the active power, reactive power, and apparent power. Active power is P is equal to root 3 VL IL cos phi. Root 3 we know, VL is 415, IL we don't know, cos phi is how much? R by Z. So for IL, you know the formula VPH is equal to IPH into ZPH. VPH is 415 by root 3. IPH you need to calculate. ZPH is H plus J8. IPH and IL is same, so you can substitute the value, then you will get active power. Similarly, you can get reactive power and apparent power, right? Now see the next part. They said, and the individual wattmeter reading if the power is measured by 2 wattmeter method. Means we need to calculate W1 and W2, right? Remember now the formula for power wattmeter reading, that is cos phi is equal to cos of tan inverse of root 3 of W1 minus W2 divided by W1 plus W2, correct? So in this case we are having separate formula for W1 and W2. VL IL cos of 30 minus phi, VL IL cos of 30 plus phi. Don't write down, note down this formula. So in this question, all the two wattmeter reading we know, because total power is W1 plus W2, right? VL they have given, cos phi we can calculate it. From here we can get IL. So maximum student don't think about it, this formula, okay? So total power is how much? That is W1 plus W2, and power is equal to root 3 VLIL cos phi. We can equate it, then we'll directly get the value of IL. Instead of using this formula, we have to use this formula, correct? So you know this VPH is equal to IPH into ZPH, right? VPH is 416 by root 3. IL is equal to IPH that you have calculated from here. Then you get ZPH. And after getting ZPH, you will get XC. Okay? That will be of pure capacitor. And after getting XC, you can get C easily. Yes or no?